let's plot one full period of y equals -2. There's too many 2's there. Let's make it -3. Let's make it -3. Sorry if you already wrote that down. Let's make it -3 cosine pi halves times x. One full period. Well, the technique isn't going to change. I'm going to graph the curve first and then go from there. So I like to put in, for the cosine, I like to put in a maximum height and a minimum height just to give myself something to aim for. And I know that any cosine curve starts at, at least one, if you start at 0 and it's not shifted left or right, you start at the maximum height value, a crest in the wave, and go down from there. Good enough. I don't know if I went down quite far enough, but that's okay. Now, before we fill in, now we're essentially plotting these 5 points, right? This high point, this x-intercept, this low point, this other x-intercept, and this other high point. But to figure out what those values are, we need both the amplitude and the period, don't we? So what's the amplitude of this thing? Oh, and by the way, I'm plotting what I would call a helper function first. Sorry, I forgot to mention this. The helper function is going to be what you get when you delete this negative that's out in front. So that's what I plotted right there. Okay? And then I'll show you what the negative does in a minute. So what's the amplitude, though, of, doesn't matter if you're looking at the helper function or the given function, the amplitude's the same. What's it going to be? 3. Yeah, you take the if you look at the given function, you're going to take the absolute value of this factor out in front. The absolute value of -3 is 3. So the amplitude is 3. And then what's the period of either the helper function or the given function? It's going to be the same.
2pi times 2 over pi.
Yeah, 2 pi divided by whatever factor is in front of the x, the input, right? The input of x. So 2 pi divided by pi halves, but as you said, when you divide by pi halves, it's the same as multiplying by 2 over pi, right?
So 4.
Yeah, so you get 2 pi times 2 over pi, which means pi divided by pi makes 1, and you get 4. So your period is 4. So I'm going to label the scaling appropriately, and then I'll show you how to get the final graph, what the negative in front does. So this is just so I'm plotting two curves. The helper function, you guys might want to plot that. I should have said this before, I already drew it. You might, since you don't have multiple colors most likely, you might want to plot that helper function as a dashed curve or dotted curve, okay? Sorry, I should have said that earlier. And then, or if you have multiple colors, then make it solid. But since you're most likely just going to have pencil, make your helper function dashed, and then your final graph, make that solid. Anyway, before I get my final graph, let's label. So what is, you guys tell me, what is this hash mark going to be right here?
4.
That's going to be 4, which makes the one in the middle 2, and it makes this 1/4 mark 1, right? That's kind of nice. The 3/4 mark is 3, right? How high does it get? 3. How low does it get? -3. So if we didn't have this negative out in front, we'd be done.
Since it's negative, it's flipped out.
Yeah, so now we have to talk about, I have to remind everybody what you do if you have a negative in front of your function. So this again goes back to college algebra. If you have y equals f of x and you know what the graph of that looks like, then how can you get the graph of y equals the opposite of f of x? Remember, the curve that you graph when you graph a function is the set of all ordered pairs with input x, and for this one anyway, the output would be f of x.
You take the opposite of y, basically.
Right. But if you plot this one, it's the input of x, the output of the opposite of y. Y is f of x in the first one anyway. So, okay. So the graph, I don't think I made that clear. So let me right, let me be very clear here. If you graph this function, you're graphing all the ordered pairs x comma f of x, right? If you graph this function, you're graphing all the ordered pairs, same inputs, opposite outputs. X comma negative f of x. So how do their graphs compare? Well, all of the y values from this first graph would just be the opposite in the other graph, right? The opposite of what they were. So if they were positive y values, positive height values in the first graph, they're going to flip across the x-axis and become negative, right? Same distance from the x-axis, opposite direction. Negative height values will become positive height values, same distance, opposite direction from the across the x-axis. The x-axis is like a mirror. And we say that this graph, the graph of y equals negative f of x, is a reflection across the x-axis of the graph of y equals f of x. And that's a transformation that you talk about a lot in detail in college algebra, but that's the gist of it. So now, if I know that this graph in red is the graph of my helper, y equals 3 times cosine pi halves x, what is the graph of the given function, y equals negative 3 cosine pi halves x, going to look like? Well, you'll reflect the helper across the x-axis. So that just means that every point on the graph, so the 5 points we plotted, you'll just want to reflect across the x-axis. This point at a height of positive 3 will reflect down here. This point on the x-axis doesn't go anywhere because what's the y value of a point on the x-axis of an x-intercept? It's 0. So how do you reflect 0 across the x-axis? You don't. It stays where it's at. This point right here reflects up to where? Well, it's at a height of negative 3, so it reflects up to a height of positive 3. This point on the x-axis stays put. This point right here is at a height of positive 3, so it gets reflected down here to a height of negative 3. And you graph the inverted graph, the upside down version of the graph in red is your final picture. There we go. A little bit more like that. You get the idea. So the graph in green is the final picture.